Hey guys, today we're going to add a couple more sections of identities to add to our formula charts to have more tools to use to be able to simplify or verify or even solve. We're going to start with a group called the even and odd identities. So what this is it's talking about our 6 trig functions, which ones are even, which ones are odd, and what assumptions we can make because of that. So if you have your trig formula sheet, this would be the title or the topic of one of the sections. And actually you're going to be, if you have made a formula sheet like I've instructed you to do so, this is going to go in that little bitty middle section of the front side. So the even and odd identities, let's just write them and then we'll talk about why they are the way they are. So the first one I'm going to write is the sign of a negative theta is going to be equal to negative sine of theta. And if this is true, then the reciprocal is true. So the cosecant of negative theta would turn into negative cosecant of theta. Let's go with tangent. Tangent of negative theta is equal to negative tangent of theta. And the same thing would be true about the cotangent. So right now it's not going to seem super familiar, but once we relate it back to graphs and even the beginning of the year, I hope it's going to make much more sense. And the cosine's the only one that's a little different. So far you've noticed everything when I plug in a negative, it makes the entire term negative. But with cosine, when we plug in a negative, it actually is going to come out the same as the positive version, which means secant is going to operate the same way. Okay, so now why is that is going to be the question. This is all that needs to go on your formula chart, guys, but I do want to show you why this works. If you remember the graph of cosine, okay, cosine looks like this, and then it keeps going in the opposite direction. And when we talked about this in class, this graph has y-axis symmetry. And you may remember from earlier this year, when a graph has y-axis symmetry, it's said to be an even function. So what is really happening here, and what we are saying is that if I were to look at a negative angle, now remember the negative angles are over here on the left side. So if I chose any random negative angle, let's say I'm right here and I looked at the graph, what it's saying is that it's going to give me the same value, like this point right here, as it would if I went to the positive version of that angle. So like this would be the theta, this would be the negative theta, and then these would be the cosines of it. And see, notice they're the same y value. And so even functions, when you plug in a negative, it's going to be the same as the right and the left side are going to be the same. And so that's why this is happening. Whereas with sine, and I'm not going to do all of these, I'm just going to do a couple. So with sine, we have this graph, right? And then it repeats in this direction. So with sine, what we're saying is if we were to plug in a negative theta, and we look at where it is on the curve, and then I go to the positive theta of that, well, look at where their y's are. This one's down here and it's negative, and this y is the same value, but it's up here and it's positive. So these are in opposite quadrants, so to speak, and that is why when you evaluate the left and the right side of this y-axis here, we've gotten the same theta in both directions, but they need to be opposite of one another, and that's why you're getting a negative right here. So that's just the whole even and odd thing, and if you care, this was an odd function because it has what's called origin symmetry. Okay, so this all ties into the concepts we've talked about all year. But these you can use. So if you're in the middle of a problem and you see a cotangent of a negative theta, just understand it means you can turn it into a negative cotangent normal theta. And that's what I would do. Usually I would never turn something into this side. I would just take something weird like that, and my goal would be to turn it into that side of the equation. Okay, so the next set that we're going to add right next to this in that little middle section, these are going to be called the cofunction identities. Cofunction identities. Okay, so with the cofunction identity, that's the title. And once again, we're just going to write them and then we'll talk about why they work. Okay, so let's see. The first one would be that the cosine pi over 2 minus theta is equal to sine of theta. And maybe we'll do the secant of pi over 2 minus theta is equal to the cosecant. And how about the tangent? Okay, and actually there are 3 more of these. If you want to write them, you can, but it's basically, guys, it's these 3 again, but you can just switch out the words, okay? So in other words, like this one and this one can totally swap places. Secant and cosecant can swap places. Tangent and cotangent can swap places. What it's saying, and I think a lot of you, this will make sense even without looking at a graph. What it's saying is that the graphs of sine and cosine differ by pi over 2. Same thing with secant and cosecant. If you imagine the graphs, if you pick up one of the graphs and you shift it an increment of pi over 2, then a lot of stuff is going to match up on the other curve. So that's all that this is saying. And it's the same thing, like, just to help it make sense in your head, pretend that you're plugging in like pi over 3, okay? So basically, if we say that theta is pi over 3, then what we're saying is that the cosine of pi over 2 minus pi over 3 must be equal to the sine of pi over 3. Well, we know the sine of pi over 3, or we still should know that. That's the y value at pi over 3, and that's 1/2, okay? Actually, I'm a liar. That's not that. That's root 3 over 2, isn't it? Haha. Okay, so that is root 3 over 2, okay? Now this, you might have to do a little math first. So if I get a common denominator of 6, that's going to be 3 pi minus 2 pi, that's going to be pi over 6. And what's the cosine of pi over 6? Well, it's root 3 over 2. So by plugging in a couple of angles, you can see that these are going to be true. But same thing I said before, even if you don't understand why it's true, just understand that these work and that you can use them and they are always true, and you can swap out one for the other. Okay, so those are the only new ones that are going on your identity sheet, and you'll have some practice problems where you'll get to put these into use while simplifying or verifying.